Hi everyone. So today here we are going to give you a rule for differentiations. So I give you some rules. So let me summarize what I gave you last time. What I gave you last time there. Let me summarize it. Last time I gave you here is limit, definition of the derivative, f prime of a. It will be limit h close to 0, right? F a plus h minus f of a over h. And this one here, we mentioned that you can do that algebraically or you can use that numerically. So that is, you can solve that numerically, all right? How to do numerically here? Just take h close to 0 from the right, from 0 from the right, and h close to 0 from the left, right? And that's called numerical. Or algebraically here, try to simplify as much as you can. At the end, you take the limit. So today here we are going to give you something very different. That is it's called definition of the derivative. And also I mentioned to you last week f prime of a, that is also give you the slope of your f when at x equal a, and also give you what's called the slope of the tangent line of your tangent line for f at a x equal a. And also I call it instantaneous rate of change of your f at x equal a. I give you that fourth time. So today here is I'm going to give you one of the rule number one, some rules, so that we are going to use it from now on. What is the rule number one? If you have f of x equal x to the power n, what is your n? N here is any constant, just a constant. Just a number. It could be real numbers, 0, 1, 2, 3, negative 1, negative 2. All of this is just a number. So what is the formula here for this derivative? The formula for this derivative here is f prime of x. It will be n. So sometimes we write f prime of x like this, or sometimes I write it as df by dx. The derivative of f with respect to x. As you can see, your f is a function in what? In x. Your f is a function in x. Then I have to take the derivative of f with respect to x. So what is the derivative? Here is your exponent n. That's called polynomial of degree n. I put n in front, and then I reduce n by 1. I reduce the exponent by 1. So I'm just putting n in front, and then I reduce n by 1. So you have n x to the power n minus 1. All right. So let me give you some example here. Also, you see, just let me write it as a remark. What is the remark I have here? If you have n equals 0, so like for example, f of x equal just n equals 0. So what did you get? What is x to the power 0? X to the power 0 is 1. X to the power 0 is 1. So f of x equal 1, that's kind of constant here. So what is the derivative of any constant here? So what is your n? If I try f prime of x, I try to apply this rule. What is your n here? Oh, my n here is 0, so I put 0 in front, and then I reduce that by 1. So if you have 0 multiplied by any number, what did you get? You get 0. So f prime here means the derivative of any constant should be 0. So let me write it. So the derivative of any constant should be 0. The derivative of any constant should be 0. Should be 0. Okay. So it will be 0. So the derivative of any constant is 0. All right. So is 0 according to what I mentioned to you here is 0. I'm just writing in word. Or let me show you by these definitions that I mentioned up here, f a plus h minus f of a, right? So what is f of x equal 1? What is constant here? Constant means if you have a constant, like 1, for example, here, it's a horizontal line. That is your y equal horizontal line. So if I have y equal 1 here, that is your f of x, the graph here, y equal f of x, and that is my x, right? And that is your y equal 1, or that is your f of x equal 1. That's horizontal line. So now if I use the definition here, which is, what is my definition here? The definition here is, if I ask you what is f prime of 1, you tell me, oh, limit h close to 0, f of 1 plus h minus f of 1 over h, right? So here when I have 1, x equal 1, what is your value of your f? If you make vertical line, what is the value of your f? Is what? Is 1. That is where it's a horizontal line, y equal 1. So f of 1 equal 1. So what is 1 plus h? 1 plus h, it could come from the right or come from the left. If I come from the right, so if you make vertical line here, then what is your value of your f? Again is 1. If I come from the left, what is the value of your f? Is 1. So what is the limit here? It will be limit h close to 0, f of 1 plus h, which is 1, minus f of 1, which is 1. So you have over h. So 1 minus 1 is 1. 1 minus 1 is 0. 0 over any number, you get 0. So here, that's another way to tell you the derivative of any constant is 0. Another way, another proof to the derivative of any constant should be 0. All right, so let me give you some, we solve some example here for this sheet here. So what is your f of x? Your f of x here is what? X to the power 7. So I need to take the derivative. So if you have your f of x equal x to the power 7, so what is your n here, guys? Oh, my n here is 7. Your n here, remember, what is the formula? F of x there, up here. Your f of x equal x to the power n. And then I put n in front, and then I reduce the exponent by 1. I reduce the exponent by 1. So here you have 7 f prime, the derivative. I need to get, what is my n? 7. And x 7 n minus 1, that is your n minus 1. You simplify that, you have 7 x to the power 6, x to the power 6, right? So let me solve this one here. What did you have here? The other one here is, right? So if I go here, x to the power minus 5, x to the power minus 5, right? So if I try to have x to the power minus 5, then what is the derivative of x to the power minus 5? Right, so just we x to the power minus 5. So you have g of x here equal x to the power minus 5. So what is your n here? Oh, my n is negative 5. So your g prime, the derivative, or sometimes we call it gg with respect to x, because your g is a function in x. So what is the derivative? Your n is negative 5. I put it between bracket, and here minus 5 minus 1. So that is your n minus 1. N minus 1. You will simplify that. You have negative 5 x to the power negative 6. Negative 5 was negative 1. You get negative 6. All right. So that is, then I go for the second one here. You have your y equal x to the power negative 3 over 4. Right. You have negative x to the power 3 over 4. If I need to take the derivative of this, what is your n? Your n here is negative 3 over 4. And here your y, what is your x? That is your m. It will be x minus 3 over 4 minus 1. Minus 3 over 4, so that is your n minus 1. So if I simplify that, negative 3 over 4 minus 1, I could simplify it as negative 3 over 4. 1 here, I could write it as negative 4 over 4. So which is negative 7 over 4. Negative 7 over 4. Right? So x negative 7 over 4. Negative 7 over 4. And that is our derivative. Okay? So that is rule number 1. If I give you another rule here, that's it. I give you, how many rules I gave you up? 2 rules. What is the first rule? The rule number 1, the derivative x is over n, it will be n, x n minus 1. What is the second rule? The second rule, the derivative of any constant should be 0. That's rule number 2. Rule number 2, the derivative of any constant should be 0, right? So now I'm going to give you here as rule number 3. What is the rule number 3 here? Rule number 3 is you have f of x plus or minus g of x. What do you have in the middle? The middle here is plus or minus. Then it takes the derivative of the first one plus or minus the derivative of the second one. So you have to take the derivative of the first one plus or minus the derivative of second one. So this one here comes from where? If you recall the derivative, what is the definition of the derivative? Limit. If you remember, I mentioned to you before, if you have limit f of x plus or minus g of x, then what is the derivative of this? The derivative of this is limit your f of x plus or minus limit g of x. So this formula here, or this rules, come from this limit, because if you go up the definition of the derivative, what is the definition of the derivative? Limit h close to 0, f a plus h minus f of a over h. So if you have, that's a limit, that is f prime of a, then what is g prime of a? G prime of a, it will be limit h close to 0, f a, g, just replace f by g, then this formula come from the limit, because limit f of x plus or minus g of x, it will be limit f of x minus. So here's the derivative. You can distribute if you have in the middle plus or minus. If you have in the derivative plus or minus. What is rule number 4? Rule number 4 here, I have to give you, okay? What is rule number 4 here? Rule number 4 here is, if you have, maybe I should write it, rule 4 here. What is that? It will be, if you have constant multiply by f of x, I need to take the derivative of this. If you have a constant and the derivative f prime, it will be, it turns out you can take the constant outside of your derivative, right? You can take the constant outside of your derivative. So now if I take the constant out, so what do you have? Your constant, what is left inside the derivative? F prime of x. So I can grab the constant outside, and then what do you have left? F prime of x. So that is the rule I'm going to use today for this one here. So now if I go for this problem here, what is given here? You have b is a function in what? In q. So here I have q cube minus 5q square plus 2q minus 7. So now if your b is a function in q. So now if I take the derivative with respect to q. Like when I up, you have your f is a function in x, then the derivative of f with respect to x. So now how to take the derivative of dq here, and here q cube minus 5q squared plus 2q minus 7, right? So what do you have in the middle? Minus. You have here plus, you have here minus. Then according to the rule up, if you have f of x plus or minus g of x, then you take the derivative term by term. The derivative of the first term, whatever you have. If you have here in the middle plus, write plus. If you have in the middle minus, write minus. Then you take the derivative term by term. So if I do that here, what is the q? So I am going to take the derivative term by term. So the derivative of the first term, q cube, and here the derivative minus the derivative of the second term, and the derivative of the third term, and minus here the derivative of the last term, which is 7. What is the derivative of any constant here? The derivative of any constant should be 0. I mentioned up, the derivative of any constant should be 0. So this term is 0 was the derivative. So now what is your n? My n is 1. Your n here is 3, and then your q, it will be 3 minus 1, n minus 1. And here that's a constant, multiply by q square. What is the rule I mentioned? If you have a constant, multiply by f of x. Try to take the derivative of this. Then if you take the derivative of this, what do you have? You will have, take the constant outside, and then what do you have? You have f prime. Then that it will be 3q, 3 minus 1. And here minus 5. I take the constant out. So what do you have inside here? You have q square. What is your n? 2. So you have 2, q, 2 minus 1. Close the bracket, n minus 1. And here take 2 out. Then what do you have? What is q here? You have, I can grab 2 outside of my derivative. What do you have left? Q to the power what? 1. So what is your n here? 1. And then you have q 1 minus 1, q minus 1. If I simplify that, you have 3q square minus 5 multiplied by 2, you get 10q. And here what do you have? You have left 2, because q 1 minus 1, what is that? Q to the power 0. Q to the power 0. What is q to the power 0? Q to the power 0 means you have q to the power 0 is 1. So that is our derivative. Alright, so what is the question? The question here, they ask you what is dp what is dB with respect to q when q equal what? Your q equal 4. So you have your q equal 4. Then I took the derivative here. Then go ahead and replace q by 4. So you have 4 square minus 10 multiplied by 4 plus 2. If I simplify this, you get 48 minus 40 plus 2. Then if I use technology, you get 10. So that is the derivative of p with respect to q when q equal 4. And the same one, if I ask you the same question, I ask you what is the slope of your f of x, the slope of your p at x equal 4, at q equal 4, q here, q equal 4, then the slope is what? Is 10, just 10, equal 10. So 10 here, it gives you the slope of your p when q equal 4, or the slope also of the tangent line of your so that is, if I ask you the same question, find the slope of the tangent line, the slope of the tangent line of p, your p here at, or when q equal 4, that is also give you the slope of your tangent line. All right, so now let me solve this one here. So for C here, try to solve this one. So what do you have? You have 5. Your y here is 5 over 14. X is about 4. So look what you have. It looks here is given as a fraction. You have a fraction, but 5 over 14, what is 5 over 14? That's a constant. You can use decimal. We use technology to have decimal. So this one is nothing but is a constant multiplied by x to the power 4. So now if I take the derivative of this, you have 5 over 14, right? X to the power 4 prime, the derivative of this, that is a constant. If you have a constant multiply, then you can take the constant outside of your derivative. Take the constant outside of your derivative, and then what you have x to the power 4 prime. X to the power 4 prime. So what do you have? You have 5 over 14. If I put 4 in front, then you have x 4 minus 1. 4 minus 1. If I simplify that, you have 20 over 14. X to the power 3, x to the power 3. And now they ask you what is the derivative when x, the derivative y prime at -1. So y prime at -1 means your y is a function in what? In x. Your y is a function in x. So they tell you what is the derivative, what is the value of your derivative when x equal -1. So I have to replace x by -1. Replace x by -1. So what do you have? You have -20 over 14. So -1 cubed, it's -1 multiplied by this. So you have -20 over 14. And also that is give you the slope of your y, or give you the slope of the tangent line for y. But what I really care, if you have 5 over 14 multiplied, that's like a constant. If you can separate the constant from your variable or your unknown, and then it will be easy to handle. It's easy to handle. Okay, so now I try to go for this one here. They ask you to find s prime. Okay, so maybe I go for the other ones here, because this one very much is the same like up. If I go for question number 3, because of the time here, look what you have. You have really fraction here. Look what you have. F of x equal 1 over x to the power 10. Now what you have x to the power n. So I have to take this one here up. So I have to recall for you here. Recall what you have to recall. F of x equal x to the power n, right? So so you have x to the power n, and then the derivative of this, it will be f prime of x. It will be n xn minus 1. But I need to recall here, if you have 1 over a to the power m, right, or 1 over to the power m, then if you take this one here up, it will be a to the power minus m. It takes the opposite sign of your m. So if you have m, it will be negative m. If you have m, you have negative m. All right, so that is the rule here. We should really know how to use this one. Then if you have 1 over x to the power 10, That is your f of x. If I take this one here up, it will be x to the power negative 10. If I take what is the opposite sign for your exponent, 10 plus 10, then you have negative 10. Then it's easy. Now here is the rule, your n is 1, negative 10, so f prime of x, it will be negative 10, that's a constant, x minus 10 minus 1, n minus 1, so you have negative 10, x to the power negative 11, x to the power negative 11, and that is your derivative f prime with respect to x, or sometimes we write it like this, f prime of x, or df by dx. All right, so that is something we have to know. So now I have another example here. You have 1 over 5 over x. So your g of x is 1 over 5 over x. So now that is a fraction. I'm going to show you this week how to get the derivative of the fraction, but here we are going to restrict ourselves to apply this rule, which is n, if you have x to the power n. So now how to make this one as a x to the power n? This one I could write it as 1 over 5, 1 over x. Can I separate this one as 1 over 5 multiplied by 1 over x? Yes, you can. And then 1 over 5, that's a constant. I'm not worried about it. I can leave it as it is. I should really give attention to your unknown or variables. So now, what is x to the power what? Oh, 1 over x to the power 1. X to the power 1. So x to the power 1, according to the rule here, look to the rule here, if you have 1 over a to the power m, then I take the opposite. When I take that up, you have opposite sign, negative m. So what is here? You have 1 over 5, 1 over 5, x to the power negative 1. It will be negative 1. Why? Because your exponent 1 plus 1, your exponent x to the power 1, take it up, it will be negative 1. Now it will become very easy. G prime of x, it will be 1 over 5, x to the power negative 1 prime. Now we have a constant. I can grab the constant outside of my derivative, right? That's a prime. What is my n here? Your n is negative 1. So you have 1 over 5, negative x minus 1, n minus 1. So you have negative 2. So you have negative 1 over 5, x to the power negative 2. Negative 1 over 5, right? Negative 1 over 5, x to the power negative 2, right? So that is our g prime of x. G prime of x. Okay, guys? So that is what you have for this one. Now I have to go for other type of problem. It's called the radical, how to get the derivative of radical here. So let me recall for you here how to switch from radical to exponent. How to switch from radical, just write the recall before I solve this problem. If you have a to the power n, so here m and here n. All right, so if you have that, so that's called m root of a to the power n. How to simplify this? It will be a to the power. You take always the exponent from inside to divided by the exponent outside. So it will be n over m, n over m, n over m. So now if I write here a to the power, it's just the square root of a. If I don't write anything here, means it's 2. If I don't write anything, your m here is 2. So what is a to the power what? 1. So it will be a to the power 1 over 2. A to the power 1 over 2. Okay, so now if you have square root of, so I'm just try to, before I solve the problem, here you have 5, and you have here 3. So how to simplify? That's fifth root of a to the power 3. If I make that as exponent, it will be a. What is inside 3? What is outside 5? So it will be 3 over 5. 3 over 5. All right? So that is something we should really know. So now if I go for this one, it will be y. Which root here? You have fifths here and x cubed like this. The whole thing is about negative 1. So what do you have? You have a bracket. A bracket is about negative 1. So now whatever inside the bracket, I need to simplify. It will be x. How to make that exponent? It will be what is inside 3. What is outside 5? It will be 3 over 5 to the power what? Negative 1. 3 over 5 to the power what? Negative 1. But let us also recall here, if you have two exponent like this, how to simplify this? Exponent here and exponent outside, so you have n multiplied by m, n multiplied by m. So this one, inside 3 over 5 and outside negative 1. So you have x minus 3 over 5. X to the power negative 3 over 5. X to the power negative 3 over 5. Alright? So now I need to take the derivative of this. It will be very easy because your n is 1. Your n here is negative 3 over 5. So it will be negative 3 over 5. X to the power. X to the power what? X to the power n minus 1. So n minus 1. Right? So it will be n minus 1. So here it will be minus 3 over 5 minus 1. You can simplify this. It will be negative 3 over 5. You can use technology for here if you want. It will be just negative 1.6. Negative 1.6. Right? If you want to use technology for this one. Alright? Alright. So here that is for x to the power negative 3 over 5. So now I need to solve more problems. So if I go for this one here, right? If I go for this one here, then let me show you how to solve this one. Okay. So here you have s is a function in one. Your s is a function in t. Your s is a function in t. So what do you have? You have square root of 5 multiplied by t. If I separate those together, you have square root of 5 multiplied by square root of t. Square root of 5 multiplied by square root of t. So if you want, you can write this as 5 to the power 1 over 2. Because what do you have here? 5 to the power what? 1. 5 to the power 1 outside 2. So 5, 1 over 2. And here t, 1 over 2. 5 to the power 1 over 2, that's a number. It's a constant. It's easy to, you can easy to simplify. So if I write, remember, as you can see, ds by dt. Your s is a function in t, so the derivative with respect to t, or you can write it s prime of t, the same. If I take the derivative of this, 5 to the power 1 over t and 1 over 2, the whole thing prime, that's a constant. I can grab it outside of my derivative. And then what is inside? You have 1 over 2 prime. If I simplify this, you have 5 to the power 1 over 2, that's a constant. What is the derivative of this? It will be 1 over 2 t 1 over 2 minus 1, n minus 1. Simplify this, you have 5 1 over 2 1 over 2 here, that's a constant, and your t to the power negative 1 over 2, right? So that is our, so now I need to, they ask you what is s prime at 5. Your t is what? Your t, so the s prime at 5, it's like, I can write it like this, ds by dt when t equal 5, when t equal 5. So now that is 5 to the power 1 over 2. Just replace t by 5. So 1 over 2 here, I write it as it is. What is your t? 5 to the power negative 1 over 2. So now I can combine those together. Combine those together. You have to recall, if you have, recall here, if you have a to the power n multiplied by a to the power negative m, or just m, right? Just m, right? So you have to simplify this. It will be a to the power n plus m, n plus m. So if you have 5 to the power 1 over 2, that is what we have, right? This one and this one. 5 to the power 1 over 2 multiplied by 5 to the power negative 1 over 2. According to this rule, your base, what is my base? 5. What is my base? 5. The same base. Then I can combine those together. It will be 5. 1 over 2 minus 1 over 2. I'm adding those together. 1 over 2 minus 1 over 2. I'm just adding. So what do you have? You have 5 to the power 0, which is just 1. So if I go back here, if I replace 5, this together is 1. So what do you have left inside? 1 over 2. So you get 1 over 2. Because when I combine those together, 5 to the power 1 over 2 with 5 to the power negative 1 over 2, you get 1. The whole thing multiplied by 1 over 2. So that is what you have. Alright? Alright. So now I solve maybe another one. This one here. What do you have? You have h. Let me solve this one here. What do you have? You have h of r. I need to simplify this one here before I'm going to take the derivative, right? So you have h of r equal to negative 4 r third root of r. So now how to combine this, whatever you have r here. Look what you have, square root of third of r. How to simplify this? It will be r to the power. What do you have here inside? Oh, r to the power 1, r to the power 1. So you have 1 divided by 3. So right, so this one, it will be negative 4 r to the power 1 multiplied by r to the power 1/3. This one here 1/3. So if I combine them, you have negative 4 r 1. When I add those together, what is your base? Your base here is r. What is your base? R. According to here, this rule, a to the power n multiplied by a to the power m, it will be just adding 1 with 1/3. It will be 1 plus 1/3. I combine those together. How to combine those together? So you have, if you have 1 plus 1/3, I could write 1 here as 3/3 plus 1/3. So what did you get? You get 4/3. So this one, your h of r, now I could write it as 4 r to the power 4/3. Now, can I take this one here up? Right? If you have a to the power, let me show you here. If you have 1 over a to the power n, what do you have here? It will be a to the power negative n. I take the opposite sign of this. 4 here, that's a constant. I leave it as it is. I take this one here up. You have negative 4/3. Negative 4/3. Now, I can take the derivative of this. So what is your derivative? H prime of r. It will be, that's a 4, negative 4/3. The derivative of this, it's a constant. I can take 4 out. I can take 4 out. So now, what do you have if I take 4 out? All right, if I take 4 out here, you have inside r to the power negative 4/3 to the power negative 1. Then what is the derivative? What is my n here? Negative. So you have 4 outside, and inside you have negative 4/3. That is my n. N minus 1. N minus 1. I close the bracket. You have n minus 1, right? So you have n minus 1. N minus 1. So how to n minus 1, right? So here you have here, so this one minus 1 here. So you have minus 1, close the bracket. So here, if I simplify, then you have 4 multiplied by 4, you get negative 16/3. 4 multiplied by 4, you get negative 16/3. And here you have r, negative 4/3, negative 4/3 minus 1. I combine them together, so you have negative 4/3 minus 1, which is negative 3/3. So you have negative 7/3. So you have r negative 7/3. All right, so that is your h prime of r. H prime of r, or that is my derivative for r. All right, guys. So that is very much here for this one here. Maybe I try to solve other problem. So what is other problem here? I'm going to give you. All right. Maybe I solve number 4. What is number 4 tell you guys here? Number 4 tell you here, if you have y, look what you have. Find if y, find the equation of the tangent line. So they give you y, right? They give you y. Here is y given. Let me write y here. So y equal to, right, 5th root of x, right, minus 2x to the power by, right, by, and then by to the power 3 minus 3/x, plus 3/x plus 2/3x to the power 4, x to the power 4, right? X to the power 4. Now that is given. I need to simplify this. So now let us understand the question. Find the equation of the tangent line. What is equation of any line? Find equation of the tangent line. Equation of any line, equation of any line, right? So let me write it for you. It will be y equal mx plus little b. What is your m? Your m here, we call it slope. How to get the slope? The slope here, that's what we mentioned last time, and we mentioned today, the slope of y, it will be your y prime when x equal 1. because he tell you x equal what? 1. So your derivative at x equal 1. Your derivative at x equal 1. So that is here. Look what you have. Define dy by dx when x equal 1 means that's your slope. That's our slope, right? So what is your b? Your b here, we call it y-intercept. Y-intercept. If you recall from high school or Math 1070, how to get y-intercept. Y-intercept here is you need 1 point. You need 1 point. So now, when x equal 1, what do you mean? If I have a graph here, a point, so it should be x and y. X and y. That is your x and y. So here is x equal 1 is given. How to get y? How to get y? So I have to replace y by 1. What is by, guys? By here, if I look to your technology, by 3.14, almost 3.14. So you have to replace everywhere x replace by 3.14. So now I need to simplify this in order to how to get y. In order to get y, I have to put that in the equation, guys. So let me give it to you. Y equal, so here, just go ahead and replace x by 1. Replace x by 1 everywhere. So what do you have? You have fifth root, right, of 1 minus 2, 1 to the power by, plus by cube, minus 3. What is your x? 1. Here, what do you have? You have 2 over 3. What is x to the power 4? X to the power 4, it will be 1 to the power 4. 1 to the power 4. Then you have to use technology to get the value. Just use the value. So here you have 1. This one here is 1, and this one here also is this one 1. So you get 2. So 1 minus 2, and by here 3.14. You can use technology. 3.14 to the power 3 minus 3. And here, what do you have? You have 2/3. 2/3. So if I use technology for this, you will get here, guys, your y is 27, right? 27.7. Turn out here, guys, this one I cannot see here very well. So you have, that is by, and here you have e, guys, e. What is e? Just let me write it for you. E also, if you look to your technology, 2.7. So here you have fifth root of x, 2 to the power, 2 multiplied by x. What is here is not by, the exponent here is e. E, just I have seen that incorrect. And here by cube, minus 3 over x, and 2 over 3 x to the power 4. So what is e? 2.7. What is your by? 3.14. So just I'm going to replace x by 1. If I replace x by 1 everywhere here in this equation, and then replace x by 1, and then use technology, you will get 27.7. 27.7. So the point on the graph, x equal 1 and your y equal 27.7. So that is the point here, which is x. Let me write it. So you have x equal 1 and your y 27.7. That is your x and y. That is a point is going to help you to find y-intercept. Help you to find y-intercept. Okay. So now I need to get the slope. How to get the slope? The slope here is nothing but the derivative at x equal 1. At x equal 1. So how to get the derivative? This one, I have to simplify this equation before I take the derivative, right? What is fifth root? It will be x to the power 1 over 5. So I have to write it here. So what is your y? I simplify before I take the derivative. You have x to the power 1 over 5, right? Minus 2x to the power e. What is e? 2.7. E 2. It's a number. What is your by cube? By cube, it's a constant. By here 3.14, it's a constant. Minus 3 over x. What is minus 3 over x? I could write x as x to the power negative 1. Look what you have here. The negative 3 over x. Negative 3 over x. I can take, what do you have? X to the power 1. X to the power 1. I can take it up. It will be x to the power negative 1. And here, what do you have? 2/3 x to the power 4. I can take x to the power 4. I leave the constant as it is. Then I can write it as x to the power 4. I take x to the power 4 up. It will be opposite sign of 4. It will be negative 4. Right? So this one, it will be, and just simplify this, it will be 2 over 3 x to the power negative 4. right? Let me simplify it here. So you have 2 over 3 x to the power 4, so that you can see up, right? If you have 2 over 3 x to the power 4, then I can write 2 over 3 multiply by 1 over x to the power 4. Then I take this one up, it will be 2/3 x to the power -4. So that's what I have here, right? If now I can take the derivative. What is the good news? You have in the middle plus or minus. You have plus or minus, means you are going to take the derivative term by term. So I take the derivative of the first one. So what is the derivative of the first term? 1 over 5 x to the power 1 over 5 minus 1. So you're in 1 over 5 minus 2. What is the derivative of x? The constant, you leave it as it is. What is the derivative of x to the power e? What is my n? Your n is e, so you have e x to the power e minus 1. Now, what is pi cube? What is pi cube? Pi cube here is a constant. What is your pi? Pi is 3.14. 3.14 cube, it's meaning the constant. What is the derivative? Any constant should be 0. The derivative of any constant should be 0. And here, what is the derivative of the second one? Negative 3x. You know, what is your n? Your n -1. So you have negative x to the power minus 2, right? What is the last one? 2/3. What is your n? -4. -4, all right? -4, and here x -4 minus 1. -4 minus 1, okay? So that is what I have here. -4 minus 1. I have to simplify this as much as we can. Then after you simplify, you replace x by 1. You replace x by 1, right? So here, so you have, just let me simplify this. You have 1 over 5. What is 1 over 5 minus 1? 1 over 5 minus 1, it will be -4 over 5, right? 1 minus 1. So 1 over 5 minus 1, just to simplify this, you can use 1 over 5 minus 1. You could write 1 over 5 minus 5 over 5. 1 over 5 minus 5 over 5. If I simplify, I combine them. 1 minus 5, what is that? -4 over 5. So that is what you have. Here, -2 e here 2.7, e here 2.7, right? X to the power e minus 1. And here negative times negative, you get positive 3, x to the power minus 2. And here you have negative 2/3. 2/3 minus 4, you get -8. Right, -8 multiplied by, that's 2 multiplied by -4, you get -8 over 3, x to the power -5, x to the power -5. So that is your y prime. So now you have to use technology here, try to get your slope, which is y prime when x equal 1, or that is your slope dy by dx when x equal 1. So go ahead and replace x by 1. Replace x by 1, you get 1 over 5. Here, -2e. And here you get 3. And here you get -8 over 3. Now go ahead and use technology to find the number. I have that the number here is -4.91. -4.91, or just -4.9. So that is our slope. All right. So what is the equation then? The equation of the tangent line. The slope here is this one here is the slope of the tangent line, right? Tangent line that touch the graph here at one point. What is your point? 1, if you recall, 27.7. 27.7, that's what I have here. Look what you have, this point here, that is 2.7. So what is the equation of a line or tangent line? Did you hear tangent line? Mx. What is your m? -4.7. I need to get b, then you are done. You need to get b, and then you are done. Okay, so here guys, I don't have technology with me here. So your y equal mx plus little b. So what is your m? Your m here is -4.9 x plus b. Now what is the point here? The point here, x equal 1, and your y is 1. Your y equal 27.7. 20.7, right? So here I go back here, replace x by 1 and replace y by 27.7. So you have 27.7 and -4.9. That's our slope. X, what is your x? Is just 1 plus b. So go ahead and take this one to the other side. So you have 27.7 plus 4.9. That is equal y-intercept. That is our y-intercept. You can use technology for this. I don't have technology. So I have here, I just try to use my mind. I hope it will be correct. So what you have here, 4 with 27, you get 31, and 0.7 with 0.9, you get 1.6, right? So you get 32, right? So 0.6. So here 6, it was 1, so you get 32.6. That's your b. So what is the equation of the line? Should be m, which is negative 4.9x, right, plus b, which is 32.6, and that is our equation of the tangent line. So let me summarize what I did here. The question here, before I read, you have to read the question. What is the question? They ask you to find dy by the x, the derivative when x equal 1. The question, find dy by the x when x equal 1, which means here is your y. It's go ahead, and it's easy to go ahead and take the derivative. How? Just simplify that first. After you simplify, take the derivative and then replace x by 1. What I did that, I got the derivative is negative 4.9. That's what I have here. Look what you have. After I took, where is here? When I took the derivative, I simplify. Look what you have. I did here. I simplify first y. I simplified. Then I took the derivative term by term. Then after I took the derivative, I replace x by 1. I get negative 4.9. So that is our derivative when x equal 1. That's the first question here. And then the second question, they ask you, find an equation of the tangent line to this curve at x equal 1. So now what is the derivative here? The derivative is the slope of your y, or the slope of your tangent line. What is tangent line here? The line touch the curve or the graph at most one point. The graph at most one point. Here is the x equal 1. I have to get y. How to get y? When x equal 1, what is your y? Just replace everywhere x by 1, and then use technology. I got what? I got here is 27.7. So that is your x, and that is my y. What is the equation of any? They ask you to find the equation of tangent line. It's just a line. What is the equation of any line? Mx plus little b. What is your m? That is already found here, the slope, which is negative 4.9. Negative 4.9. I need to get y-intercept. How to get y-intercept? I need 1 point. X equal 1. What is your y? Y 27.7. So I go back here. Just try to finish the problem. Here, mx plus b. What is your m? Negative 4.9. I need to get b. In order to get y, b here is call it y-intercept. How to get y-intercept? I have to replace x by 1. I have to replace y by 27.7 in this equation here. Then I'm able to get b, which is 32.6. Then the equation of the tangent line, it will be mx plus b, m negative 4.9, b 32.6. Then you are done. All right, guys. All right. So tomorrow, next class, I think I will continue solve this sheet here, and I will stop here. Thank you.